Hello, this is Mrs. Plenda here to talk to you a little bit more about multiplying polynomials. We're going to talk about a couple of special patterns that happen when we have certain binomials that multiply, and we're going to talk about multiplying things that are bigger than two binomials. So this will be fun. First thing we're going to talk about is a perfect square trinomial. Now these follow two patterns. We have the one that is a plus b, and that's all squared. That's why it's called a perfect square, because it starts as a plus b squared. And this gives us a beautiful pattern, a squared plus 2ab plus b squared. So you see, once we multiply it out, it gives us a beautiful trinomial. So that's our first pattern that we see sometimes. And our second one is very similar. It's just when we have a minus b all squared. And this gives us a very similar pattern, only it's minus 2ab in the middle instead of plus. And that's a perfect square trinomial. Now, the main reason that we want to know these patterns is for factoring, which is the next step after multiplying. It's the reverse of multiplying. But let's go ahead and take a look at what these patterns look like as we are multiplying them out in the first place. And so over here, I have x plus 4 all squared, and since it's all squared, that means what I really have here is x plus 4 times x plus 4, right? It's multiplying by itself twice, which means, since we know how to multiply these, that I am double distributing. So x times x is x squared, and x times 4 is 4x, and then here's our double, 4 times x is another 4x, and 4 times 4 is 16. Oops, almost forgot my x on there. Then we combine those like terms in the middle, and we get a final phrase, which is x squared plus 8x plus 16. And if you notice, this is our a squared, right? Our thing that's in the first spot, squared. Our thing that's in the second spot, squared, right? And 2ab. So we've got 2 times that 4, which is 8, and then there's our other part right there. So we can see what that pattern looks like when we put it together. Now we can take a look at what this looks like box method as well. Since we have a binomial, we will have it 2 by 2, and since it is 2x plus 1 times 2x plus 1, we put that on both sides. And then just multiply into the middle. So we've got that 2x times 2x, which gives us 4x squared. We've got that 2x times 1, which gives us 2x. And we've got 1 times 2x, which gives us 2x. And 1 times 1. We've got those like terms on the diagonal, which we're going to combine for our final answer. So I've got 4x squared plus 4x plus 1. So we kind of see that pattern where we've got like that thing that's in the first spot, squared, that thing that's in the last spot, squared, and then we take the two, multiply them together, and double it, right? That's what we see in the middle. So it's this beautiful pattern that we can recognize, and we can work it backwards once we get to factoring. So let's take a look at what it looks like when we subtract then. So again, remember, if we've got that squared, right, we're not distributing this because we've got a minus in the middle. This means I'm taking this phrase and multiplying it twice. So we've got 3x minus 4 times 3x minus 4. And then I double distribute. So 9x squared, that first term squared, 3x times negative 4 is negative 12x. And then here's our double, another negative 12x. See how we end up getting 2 of those? And then plus 16. Take those like terms in the middle, add them together. I get 9x squared minus 24x plus 16. So we've got that first piece squared. That gives us that 9x squared. We've got that second piece squared. That gives us that 4. And then we multiply the two together and double it for that middle piece. Okay? Beautiful pattern. And it doesn't matter which way we multiply it. We end up seeing that beautiful pattern either way. Here's our x minus 3. That just means that it's multiplying with itself when it's squared. I need to write 2 of those. So x minus 3 and x minus 3. multiply those together. There's my x squared minus 3x. We get 2 of those. And plus 9, because a negative times a negative is a positive. So there's my 2 in the middle that I combine for my like terms. So I get double the middle. Whoops, it's not going to be plus. 2 negatives together make a bigger negative. It's plus 9 on the end. There we go. Okay, and there's our perfect square trinomials. They end up with these beautiful patterns. Okay, we've got one other beautiful pattern that happens. This is called a difference of squares, and I love these. These are great. The nice thing about these is we've already got both of them, but watch what happens as we multiply. So here's my x times x, and my x times negative 6. Let's do that double. 6 times x, that's positive 6x. 6 times negative 6 gives me negative 36. All right, what happens when I combine my like terms? Negative 6x plus positive 6x leaves us with 0 x's. So there are no x's here in the middle. That means I'm not writing plus 0, because who writes plus 0? That would be silly. We're just writing minus 36. Our terms in the middle disappear. And now you can see why it's called a difference of squares, because here's a square. Obviously, it's got a square on it. And 36 is a square number. It's 6 times 6. Okay, that's called a difference of squares. Let's take a look at that in the box. Same kind of a problem. Here's my 3x and 5, and my 3x and negative 5. And when I multiply those guys together, I've got that 3x and 3x gives me 9x squared. That 3x and negative 5 gives me negative 15x. 5 and 3x gives me 15x. And 5 times negative 5 gives me negative 25. Well, what happens when I combine those like terms across the middle? I've got a positive 15 and a negative 15. How many x's do I have left over at the end? None. I just have the squares. And because I'm subtracting them, it's a difference of squares, right? Beautiful, isn't it? Now, these are particularly nice if you can recognize these working backwards when we factor in our next lesson next week, okay? But let's take a look at these. What happens if I put the number first? Is it going to look any different? I don't know. 7 times 7 is 49. 7 times negative n is negative 7n. Let's do that double. N times 7 gives me positive 7n, and n times negative n gives me negative n squared. What happens when I combine those like terms in the middle? Negative 7n plus 7n gives me no more n's. I just have negative n squared. Well, what? Look at that. I've got a square in the front. I've got a square in the back. I'm still subtracting them. Still a difference of squares. Okay. Let's box up this last guy. So I've got x and 1 and x and negative 1. When I multiply everything together, I get x squared, negative x, positive x, negative 1. What happens when I put those like terms? Well, a positive x and a negative x is going to leave me with no x's, just x squared minus 1. And again, I've got a square on the front, and 1 is a square number, 1 times 1, and they're subtracting. Difference of squares. Okay. All right. Now, one of the reasons that we practice all this multiplying with polynomials is that we can do area problems of quadrilaterals later, and we don't necessarily have to know the specific dimensions of the quadrilaterals, just the sort of relational dimensions, right? So this first rectangle over here, the width is twice as long as the height. No problem. In order to get area, all I have to do is take these two and multiply them. So 2x times x. Well, this is what we've been practicing all along. That's going to give me 2x squared. I can find the area of that rectangle. What about this one? Oh, well, this one's going to take us 2 steps, because I see first that I need to multiply this 3 and distribute it in, and then I can take that product and multiply it with the width. So let's first do that 3 times 2x plus 1 step. So I'm distributing in. So that gives me 6x plus 3. Now I'm going to take that and multiply it with 2x plus 1. So I'm taking that width and multiplying it with the height. So then I've got 12x squared plus 6x, and 3 times 2x gives me 6x, and 3 times 1 gives me 3. Got to make sure I combine those like terms in the middle for my final answer. So I've got 12x squared plus 12x plus 3. And there is my area for that rectangle. Okay, so we can use this multiplying in the same way that we've been finding area of rectangles for a long time. We just don't necessarily have to know the exact number of sides now. All right, now here's our tough ones, right? We're going to take a look at what our multiplying looks like when I get bigger and bigger expressions. So now I've got a binomial, right, 2 terms, and a trinomial, 3 terms, that I'm going to multiply together. And I'm going to do this exactly the way that I have done before, just longer, okay? So that means x times 2x squared will give me 2x cubed. X times x gives me x squared. X times 6 gives me negative 6x. And double. Negative 4 times 2x squared gives me negative 8x squared. Negative 4 times x gives me negative 4x. And negative 4 times negative 6 gives me positive 24. Now, I still need to find my like terms. So let's see. I've got x squared and x squared. And then I've got 6x and negative 4x. Well, negative 6x and negative 4x. So I need to make sure that I put those guys together when I am doing my final answer. So I've got my 2x cubed. Then I got to put my x squared and my negative 8x squared together. So that will give me negative 7x squared. I need to put my negative 6x and my negative 4x together to get negative 10x. And then I've got just my plus 24 on the end. There we go. Okay, so it's the same process that we have done before. We just have to do it one more time, and we have to be a little bit more careful in finding those like terms, okay? Let's go ahead and do this one more time, make sure we've got it, and then we'll do it with the box. So here we go. That first term distributes. So 2x times 4 gives me 8x. Distribute again. 2x times negative x gives me negative 2x squared. Distribute again. 2x times 6x cubed gives me 12x to the 4th. And for the second one, 10 times 4 gives me 40, positive 40, so I write plus. 10 times negative x gives me negative 10x. And 10 times 6x cubed will give me positive 60x cubed. Now I got to look for those like terms. So let's see. I've got an 8x and a negative 10x. And that looks like the only like terms that I see. So when we write this, let's go ahead and write this in our standard form. So I'm going to put this 12x to the 4th first. So there's my 12x to the 4th. Then my cubed, so plus 60x cubed. Then I've got negative 2x squared. Now I need to put my like terms together, that 8x and this negative 10x. So that will give me negative 2x. And so I've got those taken care of. And my last term is plus 40. Whew, there we go. And we are all set. We have multiplied those polynomials together. So that's a lot to keep track of, and this is why I really like the box method. So let's take a look at this problem over here using that box method. So I've got 2 and 3, so I'm going to make my box 2 by 3. 2 by 1, 2, 3. So here's my x minus 2, and here's my x squared, 2x, and 1. And I know that I need to fill every section in this box with a product as I multiply all the way through. So x and x squared gives me x cubed. X and 2x gives me 2x squared. And x and 1 gives me x. Keep multiplying. Negative 2 and x squared gives me negative 2x squared. Negative 2 and 2x gives me negative 4x. And negative 2 and 1 gives me negative 2. Now notice, I still have those like terms on those diagonals. Nice, right? So let's go ahead and combine those for our final answer. So here we go. I've got x cubed. Negative 2x squared and positive 2x squared will give me no x squareds. Negative 4x and positive 1x will give me negative 3x. And then I have negative 2 on the end. Okay, now I like the box because it keeps me organized. I don't miss any of my multiplications, and my like terms are really easy to find. So let's try this last one. And again, I've got 2 by 3, so I'm going to make my box 2 by 3. So there's my 2, and here's my 1, 2, 3. 5x and minus 1. Negative 2x cubed. 4x. And negative 3. All right, let's go ahead and multiply. So I've got that 5x and that negative 2x cubed. That's going to go ahead and give me negative 10x to the 4th. I've got 5x and 4x. That gives me 20x squared. I've got 5x and negative 3, and that gives me negative 15x. And let's do this last one. Negative 1 and negative 2x cubed. That gives me, let's see, positive, because they're both negative, x cubed. Negative 1 and 4x gives me negative 4x. And negative 1 and negative 3 gives me positive 3. Now, as I'm looking at this, I see that I only have like terms on this diagonal, so they're still found in the diagonal, but my cubed and my squared are not like terms, so I will not be combining those. Okay, but everything's pretty well organized so that I can find those like terms real easy. Okay, so final answer, negative 10x to the 4th plus 2x cubed plus 20x squared minus, because 2 negatives give you more negatives, 19x plus 3. And there is my final answer. We are now professionals at multiplying polynomials.